Okay, so remember that Weber State is having a Science Saturday, November 10th at 8:30 to noon. This is hot link, so you can grab on it and register. If you want extra credit, you can type up a one-page, 12-point, Times Roman font, double-spaced, and email it to me. Okay, make sure you include your name and your period and what it is. Don't just give me a document. I have no idea. If you've missed a day, this is where you come, guys. Your quizzes are here. Your daily work's here. Even if you've left your daily work at school, you can print it off, watch the video, upload your stuff, and you're where you need to be. Okay? The ones that say period 3 or period 4 or period 1 that don't have the picture right by it, that is OneDrive linked. So you can get it through OneDrive also. Today, we are going to be using this site for daily work a little bit later, so if you'll just scroll to that point, that will help you be ready to go when we use that. Next time we are going to do a lab, so today we're going to be working on the pre-lab. After the lab tomorrow, you need to make sure that you have daily work 4.4 uploaded and then the lab uploaded because Tuesday is the test. So that's where that's going. Today we're going to talk a little bit about metallic bonding. So far we've talked about the first 2 days were ionic bonding, type 1 and type 2. Second day was covalent bonding, type 3 and type 4. And today we're going to talk about metallic bonding and alloys. And then we're going to review all the types of bonding and naming. And then we're going to do the pre-lab. And then we're going to move on from there. So here we go. First up, maybe. Okay, metallic bonding, I'm the metal copper in a metal world. What is involved? This is a little bit more involved than the others have been. So what's involved is a strong attraction between closely packed positive metal ions and a sea of delocalized valence electrons. There's an attraction between the metal ions and the delocalized electrons. So if you look at the picture next to it, you'll see that there's blue coppers and there's green tins, and then those other smiley faces that are in that picture are supposed to represent the electrons that just sort of move freely from one atom to another. They're not really shared. They don't try and get to 8 in their outer shell. They just move like a sea of water would. So what is involved again? The strong attraction between closely packed positive metal ions and a sea of delocalized valence electrons. There is an attraction between the metal ions and the delocalized electrons. What is happening to the electrons? Well, it is the sharing of many detached electrons between many positive ions where the electrons act as sort of like a glue, giving the substance a definite structure. They are a sea of electrons, and the metals are sort of bobbing in the sea. This metallic bonding allows, because the electrons are not really attached to any metal ion, it allows them to be able to conduct electricity, to be able to conduct heat, to shine, give that luster. Those electrons that are moving around allow that to happen. I know that takes a little bit of time to write down, so I'm giving you a little extra time. Okay. We all right to move on? 1 more second. 1,000. Count slow. 1,000. Got it? Okay. All right, so alloys, that's the next thing you need a definition for. There's a little teeny definition right there, but this is basically what you need to know about alloys. Alloys are 2 or more metals that are mixed. Okay, 2 or more metals that are mixed. And because they're mixed, they give different kinds of properties. So an amalgam, which is the silver that they fill fillings with, they don't use that as much as they used to, is actually made with mercury, silver, tin, and copper. That is what is in older dental fillings. They've now changed that and are using a different kind of composite. Brass, that's used in plumbing and instruments, copper, zinc, and lead. Bronze is also used in instruments and guitar strings and metals. It's copper, tin, aluminum, manganese, nickel, and zinc. Also has arsenic, phosphorus, and silicon in it. So sometimes they mix in some non-metals or metalloids that are on the edge. Cast iron. A lot of people think it's just iron, but it's iron, carbon, and silicon. So when I mix things, I get different properties. I get different tensile strengths. So if I want something that's really lightweight but has really strong abilities, I don't want to just use aluminum, because if you've ever seen aluminum foil, it just sort of crumbles, right? And aluminum doesn't have a lot of tensile strength. But if I add a few other metals in there, I can still retain aluminum's lightweightness and give us more tensile strength. So there's a lot of different ones that you can do. There's a few here that you might be familiar with. Steel. A lot of people think steel is just iron, but it's iron with copper and chromium and manganese and vanadium and molybdenum. Okay, so it's sort of cool if you ever want to just sort of, they alloy wheels we've got up there have a lot of different things in them. A lot of people say, oh, white gold. Well, white gold is actually palladium and nickel and zinc with gold, because gold by itself is too weak to hold up. If you look at sterling silver here, it's silver, copper, platinum, germanium, and zinc. So there's a lot of different things going on. Alloys, just a mixture of metals. We don't really write a name for that mixture. We give it a specific name, like here, nitrile is nickel and titanium. Nichrome, nickel, chromium, lead, manganese, and silicon. So there's not a naming system for this. It's just when they mix things together, they come up with a name to call that what that mixture is. Okay? All right, so reviewing really quickly. Covalent bonds share. Okay, so when we draw them, we show them sharing the electrons, sharing the bonds. Remember, single, double, triple bond. Ionic bonds rip off an electron. One becomes positive and has a charge. The other one becomes negative because it gained a charge. And they are electrostatically attached because of that. Okay? Metallic bonds are just putting things together that are metals and sort of meshing them up. So looking at it a different way, because that got a little messy, ionic bonds transfer electrons. Metallic bonds, the electrons are shared, but they're free. They're in a C. Covalent bond, they're shared, but they're shared in a specific place. Okay? And this is another look at sort of a metallic bond. You can sort of see the electrons just sort of flying around. When we do ionic bonds, we show the transfer by putting it in brackets and giving a charge. Putting it in brackets and telling how many moved. Remember, covalent bonds, we actually drew where they were sharing them. Okay? All right, so I need you to get your lab out just for a minute. We're going to take a minute and do the pre-lab, and then we're going to go back into notes. So, grabbing your pre-lab, I want you to turn to the second page real quickly, and then I'm going to have you work with your partner for 5 minutes after we get this down. So on the second page, there's a table, and the table next to it has A, B, C, D. You're going to put paraffin wax in A, B, you're going to put urea, C, you're going to put sodium chloride, and D, you're going to put sucrose. And then you've got to figure out what the formula is, the chemical formula. You've got a computer. You can Google, and I put this up so you can know, Google search the formula. There's a lot of different paraffins out, but I want you to use the C31. Okay? You can also Google the shape. So when it says to draw it, Google the shape. See what it looks like. Okay? If you're Google searching paraffin wax and you go to images, it'll oftentimes give you the chemical formula. Or you can go paraffin wax chemical structure and go to images on that button, and it'll show you the chemical structure. Okay? I'm going to give you 5 minutes to get this part of the lab started. So if you get done with this grid, there's a few questions that are before that that are in the reading. So between you and your partner, figure this out, get it done. If you get it all done in that 5 minutes, raise your hand, I'll come stamp it. If not, it needs to be done before you come next time. And if you're a lone wolf, if you want to pair up with somebody, you can right today. So go ahead and get that done. Yes. Okay, I'll come around for scores again right now. Whoops, it went to the next one. I didn't want it to do that. So I'll put a timer up. Let me get that up and going. Okay, I'm coming around again. If you got your score. 8. Okay, got it.
This is another 10.
Okay. 6. Last name, help me.
Williams.
Williams, Connor.
Yeah.
Okay. If you got your score, I haven't got your score for the quiz, raise your hand, I'll come get it.
I got a 9.
You got a 9?
It. I redid it right there.
Okay.
Just got 1 point higher.
All right, that's okay. 1 point higher will help your grade. Keep going back. It's this page right here you're looking for. The carbon 31. So you're going to write the name from up here. Oh, I'll have to put it back up. And then you're going to research it. Okay, I'm going to make the thing here small because some of you didn't get the chemicals. Oh, come on. I'm going to try and make it small. Come on. Okay, it went away. I'll put it back up in a minute, I guess. Or we'll hear it, we will hear it ring. Anyone else got their quiz score? 5. Okay. Okay, if you guys will work good, I'll let you do this, but I told you that I wanted to separate it, remember?
What?
No. Yeah. I put it in your interventions too.
In my intervention?
Yeah,
What's
so
that?
so counselors and admin and parents can see. Okay, so get to work. Okay, if you got a quiz score for me, let me know. If not, okay.
8 out of 10.
8 out of 10. Give me last name.
Kelly.
Okay, here we go. Okay, work together with your partner so you make it through. You research this one, I'll research this one. You research this one, I'll research this one. Otherwise, you're not going to make it. You got to use your partner.
C31 because he said to search the formula, but I can't find it.
Yeah, I can't find the
So?
formula either, so we're really confused.
So if you go to paraffin wax and you actually go down here a little bit. Go right here. I know it's Wikipedia, but you'll still get it. And scroll down right here. It's right here.
Oh, it's that.
That's it.
Do you want me to draw it like it shows it
Yep.
here?
So, no. Okay.
Or
So,
like-
and then this one's the next one,
So
and then you
that.
have to write the formula and the name.
Oh.
So again, if you get done with your lab, then you can always go to the end and start working backwards because we do have a big bunch of homework today. So you're just writing, okay, yep, but it would just have one NA, not two. And the CL would have 8 around it, dots. Okay, you might not have finished, but I wanted you to at least get a head start on that and sort of know what to do. Now, the questions in front of that, 1 through 5, those are found in the reading from the first and the back of the second page. So if you look at paraffin wax, chemical formula, and this one, I'm going to let you on a little secret. If you use paraffin wax and you look for the Wikipedia one, they actually have on Wikipedia. I know most teachers tell you don't go to Wikipedia, but it's okay to look there for this. They do have the chemical formula for C31, and they do have the structure in Wikipedia that you can use. Okay? And we're just looking for structure and shape. Okay, so I'm going to have you set that aside so you can come back to it. I want you to grab your notes again. We're going to go into notes. We're actually going to do that big map right now. So grab that big map that I did for you. I told you I would do you another map area. This is the big map. So our first question, this is to review the 4 types of bonding. Okay? So the first question is the element a metal? Who remembers where the metals are? So if you guys want to use these, you're welcome to just turn around and you put that on. And then you can turn your whole chair around. You don't have to keep cracking your necks. How many others would like boards to write on? So you don't have to crank your necks on the back. Okay, here's a board. Turn it around so you can write.
Wow,
Same with you.
that's a big board.
Yep. Want a board? Want a board? Yep. Mia, want a board? And you can turn your chair around and write. Because we are going to move forward here pretty quick. Okay, so is it a metal? If the question is, or the answer is yes, then we're going to ask another question. Is the metal in the first 2 columns, so the S block, or on the slide? That's the boron, aluminum, gallium +3, zinc +2, silver +1. We know column 1 is +1, column 2 is +2. So these are ones that we know the charge of. If the answer to that is yes, then that's a type 1 naming. That's the first type of naming we learned. So we would just have the name of the element, and the negative element would be IDE. Remember that they still have to add to 0. So I'm going to have to take whatever the charge of the first element is and whatever the charge of the second element is and decide how many of each I need so I can add them together to equal 0. If that second question, the answer was no, then if it's a metal, that's in the D, the F, or the lower P, because the S is part of that first yes, then I have to have a Roman numeral. And remember, the Roman numeral doesn't tell me how many, but it tells me the charge on the first element. And that charge on that first element, I have to balance with the charge on the second element so that they add to equal 0. So you might not want to write exactly the words I write down, but maybe something that will help you remember what you need to do there. So type 2, the Roman numeral stands for the charge on the metal, or the first element. Then I have to balance it with a charge on the nonmetal to make it add to 0. Okay, so let's go back to the first question. What if that answer was no, it's not a metal? Well, then I need to ask a question. Is it hydrogen? Is the first element hydrogen? If it is yes, then, oh, well, let's do no first. Sorry, I didn't know which one I had no. If it's no, then it's type 3. And that's when we use those prefixes, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. That's when I use those.
Are these supposed to fit?
Yeah, they're supposed to fit.
Am I just like...
This one looks like it's been worn down, though. That's
I just wanted to make sure it wasn't just me. Oh, you just have to like.
You have to
be good at
rank
them.
it. You have
Okay.
to. If they keep doing it to the point where it takes the threads away, then we got problems. And that one has only a couple threads to get it on. So try and catch them early. Okay, so you don't use charges here. It just tells you how many of each one. Remember, carbon monoxide, CO. Carbon dioxide, CO2. Okay, dinitrogen pentoxide, N2O5. All right? If here it was a yes, then we're going to be an acid. You sort of ignore this naming. I forgot to get it erased. So we're going to have an acid. If that acid has a hydro in front of it, remember hydro? That tells me there's just two elements, hydrogen and one other. And I use that hydrogen to balance out the charge. Okay, so that I have hydrogen, however many hydrogens I need to balance out the charge on that other one element. If it doesn't have a hydro, so no hydro, then that's when I had the polyatomics. And I had to look and say, okay, what was the ending of that acid? Did it have an ick ending? Oh yeah, that was like Thanksgiving. I ate and then I got sick. So then I looked for the polyatomic ion that ended in 8 on the back, and I balance it with however many hydrogens I need to add it to 0. If it had an OUS, oh yeah, OUS, we're going to get in a fight in an acid situation. So I'm going to change that OUS to ite and look for that polyatomic on the back, find out where it is, and then I'm going to add as many hydrogens to it as I need to balance it so it's 0. So this is just a roadmap really quickly so that you can go back and everything that we've learned, because we've learned so much in the last little bit, you can figure out, okay, that's what I need to do. There's basically just 4 types, but the acids do break down and do a little bit more after that. I'll give you a few seconds to make sure you get that all down. And you can put your own words in there too, because it might help you to remember, oh yeah, remember the Roman numeral is the charge on the metal. And oh yeah, remember the prefixes like mono, di, tri, tetra, that kind of thing. And oh yeah, on the acids, I don't change the number of polyatomics I have or the number of the last element. I'm changing how many hydrogens are with it to balance it. So my hydrogens are the number that changes. And you're welcome to take a picture if you need to take a picture. This will be up on your Canvas, so you can see it again if you want to go back through it. Give you about another minute, and then we're going to use the back side of this to take a few more notes. Because I don't think she gave you enough room on your notes to do what we need to do before we go into actually doing your assignment. Now, as we get to this next part, and even as you're waiting right now, you can go ahead and start at the very back of your note packet and start working on problems coming forward. Don't start at the first of it because we're going to be using a site to do that. But go ahead and start at the back and start working forward, and that way you'll get done when you need to get done. I'm only going to pull you together here for about another 5 to 10 minutes, and then we're going to let you go to work on your own. Okay, make sure you've made that map something that will be helpful to you. This is something I would probably hold on to. It's going to be part of the notes and the assignment that you upload to me, both sides of this big map. So I can see how you used it. Okay? On the back side, if you'll number 1 through 12, if you're done with that. If you're not done, quickly finish your map. If you are done, flip your map over and number 1 through 12. I am randomly going to pull people up to put answers on the board now. Okay? You're going to practice using your map how to name the different, or how to write the chemical formulas for the different named chemicals. Okay? We okay to move forward? All right. Here we go. Here's your chemicals for the first 6. Write the name down and then give me the formula. So write the name down and then give me the formula. These are the first 6. I'm going to call random names. If you need help to fix your chemical, then let me know. I'm going to call random names to come put it up on the board. I'll have a chance to write it down first, and then I'll call the random names. Okay, Destiny, I'd like you to do number 1. Jocelyn, I'd like you to do number 2. Excuse me. Jean, I'd like you to do number 3. Hannah, I'd like you to do number 4. That's type 3 naming. Jocelyn, that's type 3. Evelyn, I'd like you to do number 5. And Omar, I'd like you to do number 6. So as soon as you get yours done, go ahead and put it up. If you need help, just raise your hand, I'll come help you. The rest of you, try and get them all done before they all get up. So to see if you can do it on your own. You should be able to write with 2, 1 on each side. So the formula. Okay, we're almost there. Oh, you forgot one thing. Come here, come on back up. What's an acid have to have? You guys help him? What's an acid have to have? Hydrogen. So we need to put a hydrogen in front of that. Just an H. Yep, done. Okay, so how do we do? What do you think? If you got these correct, you're doing awesome. Remember, anytime it says acid, I know that I'm going to have an H+. Okay? Then I just have to look here. Ich, that came from 8. Us came from ite, so I'm looking at sulfite. And hydro means I've just got hydrogen, and what other element had to be chloric. Okay? Oh, shoot. It's a big key. Okay, this one right here is type 3. It tells you how many. Hepta is 7. If you can't read that, that's a 7. And di is a 2, so that's a 2. Dihydrogen, just 2 hydrogen. Monoxide, 1 oxygen. Okay, here we go. The next 6. Yep, so, whoops. Where did I go? Yeah, I did. Oh, we did the last 7. There's the first 6. Sorry. Going backwards.
No, we did that.
We did that one? So how come it had numbers on the next one? Okay, we're just going to erase that. Okay, write these down 1 through 7. Or 7 through 12. Let's try that again. Okay, let's see who's going to get to do these ones. I'm going to give you a few minutes to get them written down and write them. You can't get in. Oh, I gave you the wrong one. That's why. That's for the very back. Let me unlock this. It's going to drive me nuts. And then I'll lock it up at the end. Oh, did one of you guys lose your periodic table down here? Move it. Stinky. Okay, let's see. Emmanuel, I'm going to have you do number 7. Sorry. Chris, I'm going to have you do number 8. Hallie, I'd like you to do number 9. Annabelle, I'd like you to do number 10. Jack, number 11. And John, number 12. So as soon as you get them done, put them up. If you need help, let me know. You do have to have all of them up.
Would this be right?
No.
It's not?
That one tells you the charge, remember? So this one has a +3 charge. What's oxygen's charge? They have to add to equal 0, so it's a common factor. 6. So how many TIs do you need to get to 6?
2 TI.
Right, there you go. Yes. Yep. Yep. You're good. Make sure you're putting the names down too, guys, because this will be a good study guide to go back to. So you have the name and the formula. The name and the formula. So if you forgot to do that, see if you can name those first 6. So name and the formula. Yeah, you can use both of them. Usually one on each side works great.
Is it N205?
Mm-hmm. So if you need help, let me know. Pretty magical, huh? I'll make it bigger so they can see it in the bag. Think large. All right. Okay, thank you. So, titanium 3 oxide. Remember when you have Roman numerals? That tells me the charge on the one before, because I walked around, I saw some of you writing that as a subscript. Don't do it. Okay, that tells me the charge. So titanium has a +3 charge and oxygen has a -2, common factor of 6. Right? How many titaniums do I need? 2. How many oxygens do I need? 3. Strontium's in the second column, so it's a +2. Nitrite's in the third column, or 3 away from being a noble gas. So again, common factor 6. I need 3 strontiums to go with 2 nitrogens, so they add to 0. Nitric acid, again, acid tells me I have an H+. Ic came from 8, so I look up nitrate. Nitrate is NO3 minus, they did it correctly, just smash them together. Magnesium, second column, +2. Nitrate, I look at the back, NO3 as a -1 charge, so I need 2 nitrates to go with magnesium. The only thing I would say here is make sure you subscript. Okay, don't just put it up. Dinitrogen tells me how many nitrogens. Pentaoxide tells me how many oxygens. Again, acid, so I know that it's going to be an H+ in front. Sulfuric came from 8, so I look up sulfate. Sulfate is SO4 with a 2-, so I do need 2 hydrogens to go with sulfate. Okay, good review? Okay, so now we're going to go into that part of your daily work where I told you we were going to go to the site. I want you to get on your computer. Keep your notes up because it's the next page in your notes. So have that open with you. So next page in your notes, it should say at the top, I'm going to sort of look over somebody's notes that I can possibly see. Oh, there we go. It says General Chemistry Daily Work, Term 2, Unit 4, C, Ionic and Covalent Bonding, Simulation, link on Canvas, Work 4.4. So, site for daily work information, that's where you're clicking. When you click there, you should get this. This should come up. Okay, so again, how to get there. Click on Home, go to Unit 4, go to Unit 4 Daily Schedule, scroll down and click on Site for Daily Work Information. Okay, and we got this. You'll actually get something that looks like this. You'll have to scroll down a little bit. Okay? Now, we're going to do the first one together so you sort of see what you need to do. So, the first one says I need to have sodium, right? Because it says pick 2 elements. Sodium, right? Am I doing that right? Somebody tell me yes. Does it say sodium? And is it fluorine or chlorine? Fluorine. So I click on that. So do what I did, and it should bring this up. Okay? Now, if I skip down, it says draw the Lewis dot on III for each atom. Do that real quick. So it's bringing up the Lewis dot for each atom, so draw it really quickly on III. They'll show it later, but then it just keeps changing from what you need at the very end to what it used to be, and that gets a little annoying. So go ahead and draw the Lewis dot. And then it asks me what type of bond is likely to form, an ionic or covalent. Here's an easy way to remember. If they are far apart on the periodic table, it's going to be ionic. If they're close together, covalent. Okay, close covalent, far apart ionic. So which one is this? Ionic. So I'm going to just choose covalent to see what happens. Watch. The answer is incorrect. Try again. Oh, so I got it wrong, so I can come back and say, oh, it's ionic. Does not hurt me. It will take me through that. So I should write ionic. Okay, now I'm going to try and figure out how many of each one I need. Okay, look at your little dot. How many of each one do I need? Na was 1 dot, right? And fluorine was 7 dots. So I'm going to have a +1 and a -1, right? So I'm going to just need 1 of each. And then I'm going to submit my answer. Now watch what it does. It shows me what's going to happen. So this right here is what I'm going to draw in my IV. So after it comes together, showing me separate, now it comes together. This part right here, that's what I'm drawing in my IV with the brackets. Okay, so I'm drawing the bracket part in my IV, and I'll keep flipping back and forth and back and forth. So as it goes to where it's the brackets, that's what you're going to put in the IV. Yes?
You sent Joshua Cussler to the counseling center.
Okay.
Thank you.
All right, so down at the very bottom of that part, underneath that, you'll need to write the formula and the name. Formula and the name. Okay? So this will be up online if you need to, or you can probably just go from now and just finish your work. Okay, so you've got 4 others that you get to do on your own, and then it goes into reviewing the stuff that we've been doing. So today's daily work is not just this page. It actually goes on and on till the end. So we are going to do a lab next time. You have to have the pre-lab done. Make sure you get the pre-lab done. You can come get a stamp from me so you can go into lab next time. Then your work right here is not going to be late until the day of the test. So keep working on it. You'll have a little bit of time, I think, next time after we do the lab to work on this also. But try and get the lab done first, then go into this. Okay? All right. Your time to work. If you need help, let me know.